Hello, this video will cover questions 98 to 102 in Chapter 4. The first question, find the point of intersection for each set of equations below using any method. Check your solutions if possible. So we have 4 questions here we'll be answering. Let's start with question A. 6x minus 2y equals 10, 3x minus 5 is equal to y. So y is solved for, so we can substitute 3x minus 5 in for y into the first equation. 6x minus 2 times the quantity 3x minus 5 is, is equal to 10. Distribute the negative 2, so that will be negative 2 times 3x, which is minus 6x, plus 10. Is equal to 10. The x's cancel, and we're left with 10 is equal to 10, which is a true statement. So that means that these two lines coincide with each other. So therefore, the solution is infinitely many solutions, but it's all the points on the line that are solutions as well. So we can say how many solutions there are, infinitely many solutions. Or we can say all the points on the line y equals 3x minus 5. If we want to prove this, because we can't plug anything in to check, if we write the first equation in slope-intercept form, and it should be exactly the same as the second equation. So let's go ahead and do that. 6x minus 2y equals 10. Subtract 6x. We get negative 2y equals negative 6x plus 10. Divide by negative 2. Y is equal to 3x minus 5, which is exactly the same equation as the second one. So that does make sense that they would have infinitely many solutions. We'll move on to question B. 6x minus 2y is equal to 5. 3x plus 2y is equal to negative 2. We'll solve this one using substitution with the x's and y's being on the left and the constant being on the right. Looks like on this one we don't have to multiply either equation by any number because the y's will cancel. So we'll get 9x is equal to 3 divided by 9. That is 3 divided by 9, so that is 1/3. And so we will take 1/3 and plug it into one of our two equations. I'll plug it into the second one. So 3 times 1/3 plus 2y is equal to negative 2. 3 times 1/3 is 1. Subtract 1 to the other side. That'll give us negative 3. Divide by 2. And y is equal to negative 3/2. So we have a solution of 1/3 and negative 3/2. And once again, to check our solutions, we'll plug them back in. And there's the check below, and once again you can see that it does work for both of them, so the solution 1/3 comma negative 3/2 is the correct solution. Question C. 5 minus y equals 3x, y is equal to 2x, so this looks like a good substitution. Can take the 2x and plug it into the first equation for y, so we will have 5 minus 2x is equal to 3x. Add 2x to the other side. You have 5 equals 5x. Divide by 5. X is equal to 1. Plug that back into the equation y equals 2x. And that'll be y equals 2 times 1. So y is 2. So our solution is 1 comma 2, and we will plug those both back in and check to see that the solution is correct. And so you can see the check below, and it does check out. So therefore the solution 1 comma 2 is correct. And then the last one, D, we have y equals 1/4 x plus 5, and y equals 2x minus 9. We can use the equal value method to set these two expressions equal to each other. 1/4 x plus 5 is equal to 2x minus 9. And we'll subtract the 1/4 x to this side. That'll be 5 is equal to 2 minus 1/4 would be 1 3/4. Or I'll write it as an improper 7/4 x minus 9. Add 9 to the other side. 14 is equal to 7/4 x. Multiply by the reciprocal 4/7. And so the 7 divided by 7 is 1. 14 divided by 7 is 2. So it looks like we get x is equal to 8. Plug that back in. I'll plug it back into the second equation. Y is equal to 2 times 8 minus 9. 16 minus 9 is equal to 7. So it looks like we have a solution of 8, 7. And we will check to make sure that is correct. We should have 7 is equal to 1/4 times 8 plus 5. So 7 is equal to 2 plus 5, and 7 is equal to 7. So that works. And the second equation, we will have 7 is equal to 2 times 8 minus 9. So 7 is equal to 16 minus 9. 7 is equal to 7. So it does check out. So there are 4 problems where you can solve systems using the 3 different methods: substitution, elimination, and equal value. Question 99. Consider the equation negative 6x equals 4 minus 2y. If you graph this equation, what shape would the graph have? How can you tell? Well, we know it's going to be linear because it's in the form of x and y. You could solve for y and write it in y equals mx plus b form. Without changing the form of the equation, find the coordinates of 3 points that must be on the graph of this equation, then graph the equation on graph paper. So to find 3 points without changing the form, we'd probably plug in some input values for x and solve for y, which we can do. So I set up a table and plug in the values 0, 1, and 2. And we'll just do the work off to the side. Negative 6 times 0 is equal to 4 minus 2y. So 0 is equal to 4 minus 2y. Add the 2y to the other side and divide by 2. So y is equal to 2. Because this is linear, we really just need to know what the pattern is, and then we can go from there. So I'll do the next one, plug in 1, and then solve for y again. Negative 6 equals 4 minus 2y. Subtract 4, divide by negative 2, and y equals 5. So since we added 3 to the y value, if we add 3 again, we should get the value for y when x is 2. So we didn't change the form. We found the coordinates of 3 of the points, and then we will graph these 3 points on the graph paper here. So x is 0, y is 2. That's the y-intercept. 1, 5, and 2, 8. And then we can graph that line. Trying to graph it accurately. I'm going to get a couple more points. There we go. Now solve the equation for y. Does your answer agree with your graph? If so, how do they agree? If not, check your work to find the error. So let's go ahead and write the equation in slope-intercept form. So we want to solve for y. So let's see. I'm going to rewrite the equation so the y is on the left. Not change anything, just changing sides. So if I subtract 4, that's minus 4 minus 6x. And actually, let me delete the x first. So we'll write it as negative 6x minus 4. And then divide everything through by negative 2. And that will leave us with y equals 3x plus 2. So our slope is 3, and our y-intercept is 0, 2. So if we graphed, we would do our y-intercept first, and then a slope of 3 would be up 3 over 1, which you can see that's happened there, and then down 3 over 1. And you can see, once again, all those points fall on that line. So does your answer agree with your graph? And it does. And how do they agree? Because the points are the same. And so once again, yes, they do agree. The equation from above and the equation in slope-intercept form are the same. And we know that because the points are on the same line. 100. A tile pattern has 10 tiles in figure 2 and increases by 2 tiles for each figure. Find a rule for this pattern and then determine how many tiles are in figure 100. So, create a little table of what we already know. We know figure 2 has 10 and it increases by 2 tiles, which means it also decreases by 2 tiles. So we want to know what our starting value is, which is 6, and we want to know what the growth is, which is 2. So we can write the equation. Y is equal to 2x plus 6. So there's the rule for this pattern. And then for the 100, we're just going to plug in 100 for x. And we get y equals 200 plus 6, so 206 tiles for figure 100. So make sure you answer the question as well. 101, make a table and graph the rule y equals negative x squared plus x plus 2 on the graph paper. Label the x-intercepts. So to be able to graph this so far, we're just going to be able to use a table. And we're just going to plug in values for x and solve for y. So I went ahead and just showed the work and plugged everything in there. And you can see I did negative 3, which was negative 10, negative 2 is negative 4, negative 1, 0. 0 is at 2, 1's at 2, 2's at 0, 3's at negative 4. And so once I saw that pattern of repeat here, I just did the same thing for 2 and 3 and can do it again for 4 at negative 10 there. Okay, so I'll just plot these points and then we'll graph the parabola and label the x-intercepts. So negative 3, negative 10, negative 2, negative 4, negative 1, 0, 0, 2, 1, 2, 2, 0, 3, negative 4, and 4, negative 10. Now, it is a parabola. It doesn't go straight across right here, so it looks like it'll go a little bit above those 2 points, even though we don't know what it is right now. It's not going to go straight across, though. So that is our parabola, and we want to label the x-intercept. So one of them is right here at 2, 0, and the other one is at negative 1, 0. And there is the graph of the equation y equals negative x squared plus x plus 2. Do be careful with the negative in front. That is not part of what is being squared. So you can see on my problems where the negative is on the outside and then I'm squaring that number. Question 102. Mr. Greer solved an equation below. However, when he checked his solution, it did not make the original equation true. Find his error and then find the correct solution. So this is the equation 4x is equal to 8 times 2x minus 3. Sometimes solving the equation is one way that you can find the error, because sometimes it is hard to see, but you can see maybe on this one kind of right away 8 times 2x is 16x, but then Mr. Greer did not distribute the 8 to the negative 3. So that is the error that has occurred. So this number right here is incorrect. And then we can correct this by distributing correctly. 4x is equal to 16x minus 24. And so now we can subtract the 16x, which he did do, but it's equal to negative 24 instead of negative 3. And then now when we divide by negative 12, we get x is equal to positive 2. So x equals 2 is your solution. And if we check ours now by plugging it back in, we should see that we did find the correct solution, but we'll find out here when we get done checking. 8 is equal to 8 times 2 times 2 is 4. 4 minus 3 is 1. So 8 times 1 is 8. So 8 is equal to 8. So our check does work. So at the end there, I just added Mr. Greer distributed incorrectly. He didn't distribute the 8 to the negative 3 to get the negative 24.